Hello everyone. So in this video I'm going to be correcting my little mistake in my circuit design. If you recall, I'd put a little bit of a circuit that should come on when the power goes off, just to give some ambient light with some LEDs. Not too much, just a little. The problem there was I hadn't really thought it through, and I did it in a hurry. I knew it would work in one of the ways, so I just put something in and I got the sense wrong. So what I've done is I've put it together in KiCad, and I'm going to switch to that window in a second and show it to you. And yeah, I don't know if I can capture the, because I realize I've made a mistake there as well. I don't know if I can capture the fixing of the mistake. But anyway, this is the circuit. Guess what I forgot? Yep, it's the LED. 1 second. Yep, that's the LED. Let's rotate it right. And then let's go back here. Let's click here, delete. Click here, delete. And I find it's easier to do this. Move. There we go. That was a genius move. There we go. So I've now fixed the mistaken circuit. I'm just going to generate netlist, because that's going to give the LED a number. There, it's D1 now. Nice and easy. Anyway, so let's scroll a bit so you can see the full circuit. This is basically how it works. VCC is our battery voltage. Let's get a pointer. Ground ref is our ground. Our ground should be common between the battery charger and the battery reference voltage. So in fact, let's add a bit more circuitry here, just so you can see the full circuit. Hang on. Okay, sorry. Let me just find the correct part. I'm just going to use a normal diode here because I'm doing this on the fly. That's a normal diode apparently. And then end wire. So basically in normal operation your charger will flow in this point. Your charging current will come in and charge the battery. Should be VBAT, not VCC, but who cares, through this diode. When the power drops off, so this point drops low, what will happen is current will stop flowing, and battery voltage can't influence this resistor. So under normal circumstances, when there's charger present, this resistor will drive this transistor, which will pull down this point through this 22K to almost ground voltage, close as anything. Then basically, when that drops away, this point will rise to the battery voltage, and you'll get a current flow through here, through this 1K5, through the base to ground, which will turn on this transistor, which will in turn turn on this diode, which will light up. Now, for the sake of, let me just bring this in here. For the sake of, just getting things simplified, I'm not using the diode at this point. Let's hide this window. Nope, wrong one. So basically, don't need to see my phone. So basically, if you have a look here, I'm just going to power this on. See nice bright lights 11 milliamps. Let's just go down. Okay, I'm at 13.8 volts. You'll have to trust me. 9 milliamps. It's relatively bright. It's ambient light. No need to drive them too hard. If I connect this connector, should give you a better view of my circuit, which is exactly as I've drawn. You'll notice that the LEDs go out, and the current drops to 1 milliamp. But you say, because you've been paying attention, what happens if the power never comes back? Won't this flatten your battery? Well, you'll notice I've got 4 LEDs. So let's power fail, and I'm just going to drop the voltage on my bench power supply. Notice at 12 volts we've lost a significant amount of brightness, and we halved the current. Not necessarily the most ideal. 11 volts, we're down to 2 milliamps. And at 10.5 we're down to 1 milliamp. So under these circumstances, the battery's just charging at 1 milliamp, which isn't really too bad. And the other thing to notice, if we turn it on, it actually draws slightly more current. So what that amounts to is, when the power comes back, well, it won't matter because the power will be back. When the power comes back, the circuit will switch off the LEDs and draw a bit more current. I'm just going to increase my voltage to the 13.8 maximum. So this circuit represents, when in off state, a maximum of 2 milliamp draw, and when in on state, a maximum of 9 milliamp draw on the system. So that's about it. That will fit into the footprints I put on the circuit board, and that will drive me a little bit of ambient light. Running 4 LEDs is going to be a little bit more complicated, but I'll probably just string them together on the end of a cable. Okay, cool. Well, that should be it. Thanks everyone, enjoy.